Okay, this is question 7 with the integration and substitution method. As always, please try and attempt these and stop the video, like don't ruin the surprise. Just if you get stuck, then have a look. Okay, let's have a go. So we saw one similar to this in some earlier questions where we had, I think it was either a sine cubed or a cos cubed. And the issue is that we've just got this one function. We haven't got its derivative. So how are we meant to do that with substitution? Because with that we need a derivative function. So this is where we have to separate things a little bit. Okay, so I hope you realize that sine to the power of 5 is the same as sine x times sine squared x. And we're going to times sine squared x again. And the reason that we want to do this is, I hope you're saying it before I do, but that is because we know that we can rewrite sine squared as 1 minus cos squared x. And as soon as we've got that, you know, maybe we've got some options to see what we can do. Now, what we will do is we'll keep that sine x, and I'll replace the sine squared with 1 minus cos squared. And of course, because we've got that times again, I'm just going to put the squared there. Okay, so now we've got two functions. We've got a function times by another function, and we can see, can our substitution method work? So one of the first things we might consider is, could u be 1 minus cos squared? But we're going to quickly rule that out because, okay, if we differentiate, the derivative of 1 is 0, but we then have to look at the derivative of cos squared, and that's not going to give us a nice, easy sine squared. So as we have done previously, we sort of reduce our u function, and we consider, what if we just let it be cos x? Okay, because things start to go nicely, because the derivative of cos x is indeed our sine x here. So when I rewrite this, instead of 1 minus cos squared x, because cos x is u, I can rewrite that as 1 minus u squared, and that's squared. And then the sine x, right, this bit here, that is my du by dx. So I can actually just write that as integrating with respect to u. And like we did when we first started doing integration, we can't integrate that function, so we will expand first. So 2u squared plus u to the 4 with respect to u. And this then becomes, as we said, integrating with respect to u minus 2u cubed on 3. Okay, don't forget the plus c, and finish that off nicely by just replacing your u function. And you probably don't need to be looking at me doing this, but it's nice to finish it off. Okey-dokes. I should have paused the video and just written it for you, but anyway, there we go. Okay, so think about, with these ones, we're going to sort of try and split the terms where we can see it. All right, next one. Moseying along. So again, you have a think yourself, pause the video, see what you can do. Okay, so you've had a think, hopefully you got it right, and now you're just checking. But we have to consider, what could we let u be? And again, you could go, well, sine's got the biggest power, so we could let u be sine, but then the derivative of that is, yes, it's cos, but we haven't got just cos x, we've got cos cubed. So we can't just let it be that. So what we have to do, like we did before, is consider, where can we split? And once again, we're going to have sine to the 4x, and this time we've got cos cubed, so that can be cos squared times cos. Okay, so I can rewrite this. We can have the sine to the 4 x, and I can replace cos squared with 1 minus sine squared x times cos. So again, I'm looking at that cos and I'm going, well, that cos is the derivative of sine. So that is leading me to go, well, what if I let u be, like we've done before, sine x? And therefore, the derivative is cos x. So maybe pause the video and see what you could do next by substituting in your values. Okay, so sine to the 4, that's u to the 4. This will be 1 minus u squared. Cos x is the du by dx. And then we've got the dx, so they go. And what I now am going to do is integrate this, but would have to expand, so that's u to the 4 minus u to the 6, and I'm integrating with respect to u. And we can finish it off from here quite easily. Assuming you agree with my line there, integrating u to the 4, and then all that's left to do is replace the sine, and voila. Okay, next one. And last one for our question 7. Okay, so having a careful look, we've got, yes, we've got a cubed there, we've got the cos. In this case, we haven't got a cos squared or a cos whatever, and hopefully you're seeing that u, if we let that be sine 2x, what is our derivative of sine 2x? So go back to your rules, have a good look, and hopefully you agree with me that that is going to be 2 cos 2x. Okay, so derivative of sine f of x is cos f of x times the derivative of f of x. Okay, so we can see we've nearly got what we want over here. So we're just going to do a little bit of a shonky maneuver that we have done before. I shouldn't call it shonky, it's quite legal. So we've got our 2x. I left a little gap there because, as we've done before, I'm going to now introduce, I'm going to times that by 2, and I'm happily able to do that as long as I also times by 1/2. Okay, so not changing anything there. Technically, I'm just timesing by 1 overall. So that now becomes 1/2. Now, we're saying let u be sine 2x, so this becomes u cubed. And then 2 sine 2x is the du by dx, so I'm integrating with respect to u. And this one is easily able to finish off now. So to the 4 over 4 plus c, and therefore 1/2 times 1/4, that gives me 1/8, so it's going to be sine to the 4 2x over 8 plus c. So slightly harder ones there, you have to sort of make sure that you can separate. Hopefully that makes sense to you. Hopefully that's helped you with these 3 questions, and you feel quite confident to have a go at more of yourself by yourself. Good luck.